Friends, today we discussed about an important topic of data structure, which is searching. Okay, so there are two things here we studied in data structure. One is a searching and another is a sorting. So today we discussed about that searching. So first we discussed about that searching and sorting. So first we know that what do you mean by that searching. So searching means if one list is given and within this we find out one element, suppose 5, 2, 3, 1, 6, 10 is a given list. Okay, then we search one item which is here equal to 6. Okay, so first we search the first element, then second, then third, then fourth, then fifth, and here we are find out that 6 element which is present. So that means the searching is successful and we find out the list. And if suppose the searched item is not 6, the searched item suppose is 11. Okay, so we searched it that 5, 2, 3, 1, 6 and 10 and we are not getting the searched item. Okay, so then the searching is unsuccessful. Okay, so by using this type of technique, okay, we search that if that particular element is in the list or not, and we getting that element. So if the element we find out, that means we know that the element is in the list. Next is sorting. So what do you mean by sorting? So in the sorting, we sort the list either in ascending order or in descending order. Okay. Suppose one list is given like this: 5, 10, 2, 3, 6, then 11. Okay. So if this is the list, then we sort the list by using any type of sorting technique. So there are different types of sorting techniques we are using and we later on discussed one by one. Okay, so first we know that what do you mean by that sorting. We sort the list, okay, and the list is in any order it is given. We sort it and we find out the ascending order list. Okay, and in the question it is given that if you sort the list in ascending order or in descending order. Okay, so if it is sorted in ascending order, the result is like this. If you here sort it in descending order, the result is like this. Okay, so the sorting result is, that means one particular list is given, okay, and according to the list we sort the list either in ascending order or in descending order. Okay, so in the data structure we are discussed two concepts. One is searching, and that for that searching we are using different techniques, and another is sorting, and here we sort the list, and for that sorting also we are using different types of techniques, and one by one we discussed about all the techniques. Okay, so first we discussed about what do you mean by searching and what are the different techniques here used in that searching. Okay, so the searching is here in divided into two types. One is here linear search, another is binary search. Okay, so what do you mean by that linear search and what do you mean by that binary search? So here the linear search means here we search linearly to the particular list. That means suppose this is one list given, we search the list one after next. Okay, so first we search the first item, then second item, then third item, then fourth item, then fifth item. So whatever be the number of items, we search the item, each and every items we searched it, and we are getting if the item is present in the list or not. Okay, and binary search. Here what does it mean? That means we divide the list here in two parts. Okay, and in the one part we search if the element is present in the list or not. Okay, in the second part we search that if the element is present in the list or not. Okay, so here we divide the list into two parts, so that's why it is called as binary search. Okay, so here also we are using certain technique, and later on after the linear search we discuss this. Okay, so first we discussed about that linear search. So what is the technique here behind the linear search? First we discuss this thing. Okay, so next is here linear search. That means here the list we searched linearly, linear search. Okay, so how we search the list linearly? Suppose this is one list is given. Okay, so how we search that element is in the list or not? Here the name of the array, we discussed about the array concept before that searching and sorting technique. First we discussed in the data structure what do you mean by that array and how we store it. Okay, so we know that there are certain name for the array is there, we naming the array, and we starting our indexing like this 0 1 2 3 4 like this. Okay, so for our convenience here you naming it as A, not ARR, because ARR is too long. Here I am writing that A, it is easy for me. So A 0 1 2, then A3, A4 and A5. So what does it mean? That means the name of the array is here A, okay, and the indexing is starting from 0 to up to 5. Okay, so how many number of elements here are? How many number of elements? Here 6 number of elements. Okay, 6 number of elements are here. Okay, so why we writing like this? Because the array indexing starting is from 0, 0, 1, 2, 3, 4, 5, and here 6 number of elements are there. Okay, so suppose for example the list is like this. Look at one example: 5, 10, 3, 1, 2 and 6. Okay, and the searched item here is, searched item is given here is 2. Okay, so first what we are doing, we search for the first item if this is the searched item or not. We know that this is not the searched item, then we go to the next. Okay, so it is not the searched item, then we go to the next. It is not the searched item, then we go to the next. Okay, then we go to next, and whenever we are find out the 2, that means the search is successful and we find out the element at which position. So look at this, the position is less than the index, the position is here greater than that of the index number. This is the first position, this is the second, this is the third position, this is the fourth position, this is the fifth position. Okay, so look at this, the position is here 5 but the indexing is here 4. Why so? Because the indexing is starting always from the 0, and at the fourth position here the position is written here as 5 but the array indexing is 4. So that means here we write down the item 2 is found in the fifth position. Okay, and the search is successful. Suppose the searched item, here we write down the searched item is 20. Okay, so we searched here the first position element, the second position element, the third position, fourth position, fifth position, sixth position, and the indexing here is end and we are not getting the 20 item. That means here the search is unsuccessful and we are not getting our result that the search is successful. We know that the item is not in the list. Okay, so what is the algorithm for that? How we writing the algorithm? Is the here if we give this type of example, then it's okay for you. That means look at this: 5, 10, 3, 1, 2, 6. Once again I am telling the same thing. That means these number of elements are present in the list. Okay, we search for the 2, and if we search that 5 is equal to 2 or not, 10 is equal to 2 or not, 3 is equal to, why we are writing here equal to, that means we compare it if the item is equal to that searched item or not. So 3 is equal to or not? No. 1 is equal to no. If we are getting the 2, that means it is equal to the searched item. So the search is successful. But in the next case, if it is 20, so 5 is not equal to, 10 is not equal to, 3 is not equal to, 1 is not equal to, 2 is not equal to, and 6 is also not equal to. So that means we are not getting the searched item. That means the search is unsuccessful. Okay. So next we write down the algorithm for the linear search. So what is the algorithm? Here we write down it, and then I explain about that particular algorithm and how we write down the program. We convert the algorithm to a programming language. So first we write down the algorithm, because in data structure here we explain about all the algorithm, what is the stepwise procedure to writing a solution of any problem. Okay, then we write here the linear search algorithm. Here the linear search, within bracket we write down the name of the array is A, and the n is the number of elements, and item is the item which we want to search it. Okay, so in the algorithm here we write down, here the A is the array name. So all things we here explain that what is the A stands for, what is the N stands for. Okay, so here the A is the array name, N is the number of elements, and item is the searched item. Okay, so all these things we are written here in a square bracket. Okay, then after we start our algorithm. Okay, so step 1 we write down start, because in each and every algorithm we are writing the start and stop, or start and exit, whatever may be, you write down it. Okay, so start. Then second is step 2 is initialization. Here we initialize the values. So initialize I equal to 0 and k equal to 0. Okay, so we are here taking two variables. Okay, which I equal to 0, we start it to 0, and then k equal to 0. Then next in step 3, repeat, we write down repeat step 4. Okay, so here we write down step 4 for I equal to 0 to n minus 1. Okay, then what we write down in the step 4? In the step 4 we compare it, because the comparison is here necessary. We compare it, ai is equal to that item. Okay, so the comparison is necessary, that if that ai is equal to item or not, then k equal to 1 and j equal to I plus 1. Okay. So here, sorry, ai is equal to item. That means we search that if that particular ai which is starting from 0 which is equal to the item. So the item is given, which item we want to search. N is the number of list and A is the array name. So we are starting our searching from 0 to n minus 1. If the ai equal to item, then k equal to 1 and j equal to I plus 1. So I am here writing the next step. So step 5, k equal to, here we mentioned that if the search is successful, we are taking the k value is equal to 1. Okay. So here we write down if here k is equal to 1. Okay. So here if that k is equal to 1. Okay. So then we write down the item is present in the list. The item is present in the list. Okay. So we know that the item is present in the list. Okay. And it is present in which position? Present in the list in jth position. Okay, so why we writing here jth position? Look at this. Here we write down if we are find out the item, the k equal to 1, that means we know that the item in the list, and in which position? The I plus 1. Suppose we are getting the I is 4th position, so the item is present in the list in the jth position. Else here in each every here if is something is happened in if, then else we write down here search is unsuccessful or item is not in the list. Item is not in the list. Okay. So next is stop. So next step is, last step is, which is step 6 is stop. Okay. So we write down here stop. So this is one step, step 5. So here I underline this because if we don't know the steps, so it is not easy for us to write down the algorithm. Okay. So once again look at this algorithm. Step 1 we start it, and in step 6 we stop it. Okay. So we initialize the value of I equal to 0 and k equal to 0. Okay. So repeat step 4 for I equal to 0 to n minus 1. So whatever here I tell you the algorithm, here I explain it once again. Suppose 3, 2, 1, 6, 8 is the list. Okay. And we search the item 1. Okay. So we start our algorithm. Then we initialize I equal to 0 and k equal to 0. So we start it I equal to 0 and k equal to 0. Here A is the name of the array 0. Here A 1, A 2, A 3, A and 4. Okay, so the number of elements are 5. So n equal to, here n equal to 5, n minus 1 means 4. So I is starting from 0 and taking it as 4. So 0 to 4, and we initialize the I value 0, and k another variable we taking at 0. Okay, so here I am writing I equal to 0 and k equal to 0. So for this, repeat step 4 for I equal to 0 to n minus 1. So I is starting from 0 to n minus 1 up to A4. If ai is equal to item, so first we repeat it, that step 4. Okay. So up to I equal to 0 to n minus 1. Okay, so whenever we first starting our algorithm from that step a equal to 0, okay, then a equal to 1, I plus 1, okay, so a equal to 1, then a equal to 2, then here we know that I value here equal to 2 and here the search is successful. If ai equal to item, here we are getting the item, then whenever we are getting the item, we convert the 0 position as here 1, k equal to 1, and j is how much? J equal to I plus 1, and here the I value is what? I value is here 2 and j equal to I plus 1, which is 3. Okay. So in the step 5 it is written that if k is equal to 1, that means here we are getting the 1 value, then item is present in the list. That means we write down that the item is present in the list in jth position. So which position? In the third position. So this is the first position, this is the second position, this is the third position. Okay, we are searching for the 1. Okay, so j equal to 3 and this is we have find out the item is in the third position. Okay, and then step 6 is stop. Okay, so this is all about the linear search. Thank you.